and Salesforce, and also the fact that you've been teaching at ISB, and of course, most excitingly, the Must Research group that I was telling them about, this kind of volunteering of research work that is being done. And we look forward to hearing from you. Thank you for taking the time out to speak to us today. And we are, like I said, are really looking forward to hearing about the applications of AI research that you're going to talk about today. So I'll, hand over to you if you want to share the screen and,
Sure.
Just check that all is well there.
Okay, so good morning, everyone. And let me just share my screen. And so there is some video as well inside my presentation. I think Zoom supports that.
I
If
think
you
so. I think that
can't
should be fine.
hear, then please let me know like that time, like whether it is not working. Okay. I think I have some admin or something like so. Someone has to give me the.
No, so if you just click on the share screen at the bottom, that should work.
No. That is not coming actually. So usually for Zoom, someone has to give me like host
That
or
has
share.
not been an
Yeah.
issue in the past. Let me just see. So you don't see the share.
No. Yeah. Now it came. Now it came.
Okay, good. Super. Yes, we can see it.
Cool. Okay. Perfect. I can minimize this. So yeah, thanks everyone joining this session. And today I'll be talking about the applications of various AI research, and especially like what I have done in past, whether in Must or my first patent in IBM, or some interesting work in Microsoft, Salesforce, and Aviso. So like how we have to think out of the box, right? That's very important for research. First of all, like what is the traditional deliverable for IT industry and versus the AI and machine learning when it came or came back rather, and then how we redefined our deliverables, right? For our customers, for our consumers, for government, for students and society and benefits and all right. So to begin with that, right, I just wanted to first, yeah, first of all, like this AI or artificial intelligence is not a new term, right? It came in late 1950s, right? In 1956, Professor John McCarthy and few of his colleagues in MIT, they actually presented one paper and where they mentioned about the term artificial intelligence, which was nothing but like simulation of human intelligence, right? And at that time, there was like few programming languages. Famous was like one of them was Lisp, then Prolog. So those are the language for AI programming. And when I started my journey in back in 2002, like 18 years back, that time AI was also not so popular in the corporate world. Only few research organizations like Indian Statistical Institute, IISCs, IITs, right? So they started working on deep research and triple IT as well, right? So few of these tech universities in India, where professors and scientists they started working on AI, machine learning stuff, but not in the corporate world. Corporate world that time, like if you have a Java certificate, you will get a job. If you have a like SQL, I mean expert, then you will get a job. So that was the era, like early 2000, even just post that Y2K, right? Y2K when it came in 1999, and suddenly people thought like, okay, the computer will die and everything will happen. And then there was a huge demand rather than like how to fix the Y2K bug. but no one actually cared about all these things, which we started, like all the scientists started much early, in the earlier days, including like how to solve algebraic problem, how to play different games, right, including chess. I think you have heard about like IBM Deep Blue, which is a supercomputer. Definitely it's AI, but not machine learning. But that particular system, when IBM launched, it defeated Gary Kasparov, who was a grand master that time, in again late 90s, I think in 97 or 98, and IBM launched that. But that was not for business. So IBM launched Deep Blue just to show their power of AI research, right? So that's very important. Sometimes we may build something which is not for business, but to accomplish some of these algorithms, right? Okay, we have done this, and let's try it out, right? So that's why research is important. But definitely we have to think about like how we can convert these all these deep research into business or into some societal benefits, right? So both, right? Whether we are doing something for customers or consumers, or whether doing it for government or for ground level work for NGOs and society and all. So, so in summary, like I mean, AI is not new, right? The hype is new. Definitely, everyone is talking about AI now, including common people who are not aware of the technology, who are not tech savvy at all, not from IT domain or something. They are also talking about AI. In recent things happened, like in one of the electronics shop I just visited. I was just roaming around to have like a window shopping, and it was raining outside, so I just get into and then one salesperson came, and he said like, sir, are you looking for the new smartphone launched by Samsung? I said like, okay, show it to me. So he said like, this is Samsung Galaxy Note 10 Plus. I said like, okay, it's a big name, but I heard like some Samsung Galaxy Note, this series is risky, because in one of the models you had earlier, I think Note 7 or something, 7 Plus, that got like burst, and in most of the airlines, in domestic airlines, they are saying like you cannot carry that particular model. Like if you have Samsung Galaxy Note 7, then you cannot carry that in airline. So that's a huge, like I mean, impact to the company. I don't know, let's say. Then that guy said, sir, don't worry on this. This particular model is the latest model, and it has intelligent battery. I said like, intelligent battery? Now that's say then that guy said like, sir, so this particular phone will actually observe how you're using your phone for first 30 days, and then it will learn your behavior. Say like, my behavior? No, 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 not your behavior. It's, I mean, how you're applying like different kind of, how you're using different applications, how you're when you're shutting it down, when you're switching it off, or like putting silent. So all these things, including a number of calls, SMS. So whatever your activities in the smartphone, it will learn in this. Then I asked that guy like, okay, do you know like how it will learn? Then he said like, this is called machine learning, sir. This is called artificial intelligence and machine learning. So that algorithm is there inside this phone, and it will optimize the battery consumption. So it will not, definitely it will not blow off, rather than it will save the battery life, and it will optimize the entire performance of the phone. So that was a like so that guy was definitely not an AI ML practitioner, and I also didn't reveal who am I. So I really enjoyed that conversation. And what I wanted when you communicate here is like, so now AI is within our day-to-day life, right? We are using Siri, we are using face unlock, we are using a lot of voice commands to Alexa, even a lot of different applications where we are combining this structured data, unstructured data, semi-structured data, and then either knowing or without knowing, we are applying AI in multiple devices, in multiple systems, including the Zoom. If you see this virtual background, right, that Aurora Borealis is in my behind, right? So that's AI, right? It's actually getting like my face from the background, how it identifies that, okay, this is a human face, right? So it's not so easy, but we use it like, okay, even the TikTok, right? You have seen like a lot of things, the automatic mustache comes, or like something, fire comes on your face. So how it happens, right? It identifies the eyes, the nose, the mouth, everything, right? So it's AI, right? I mean, we, without knowing or with knowing, we are using lot of technologies on artificial intelligence. Now only thing is like, how to build that. If I using TikTok versus developing another TikTok type app, is different, right? So we have to think about those. So to think about those, definitely we have to think about a lot of innovation, a lot of innovative ideas. So we have data, we have a lot of data in different forms. For an example, structured data is like database, on which is in web or document. You can get that. I mean, you have tabular or rdbms format. It can be in a semi-structured form, right, in machine logs, some sequence of iot devices and mobile appliance and all. Think about like tomorrow, if you have a washing machine, which is like a smart system, which will have a camera, and you are putting a lot of t-shirts and jeans and all, and then after 1 week it says like, hey Joy, you have a lot of black t-shirts, why didn't you buy a blue one, right? So that kind of a suggestion the washing machine can give, or the food processor can give me like, okay, you have only this kind of ingredients, but if you have this, then probably you will get a better recipe, or better dish. Or the fridge is alarming me like you are running out of tomatoes, or two of the five tomatoes are rotten. You can like either cook, I either throw them out, or if it is early stage, like you cook them immediately or something like that. Like, I mean, gradation of whether, so multiple things we can do. And because when you're opening the fridge, the light goes on. When you're then when you're shutting the door, then it goes off, right? So in between that, what can be done, right? You can put something, you can get something, or you can rearrange something, or you don't do anything, you just opened, saw, and closed. But only four of these states can happen in between, like you and your fridge, right? That is a finite state automata. We can, there is not infinite states, right? So from there, can we actually think about like what we uh, plan, like to enhance those division. And I'm damn sure like in next 2 years we'll see these kind of devices. Rather, right now my fridge has wi-fi. I never used it, but it says like I can control the temperature from a remote location. Supposing I'm sitting in my office, and I can still control the temperature of my fridge from office. I never tried that because I didn't think like that's ai, but automation, definitely the automation is there. So now wi-fi is there. Now tomorrow there can be a camera, right? So and other things, right? I mean, microphone. So a lot of fridge sound can be censored, like, okay, this is something like, okay, there is one sensor which is actually getting the vibration of the fridge, which is behaving abnormally, and then it is showing like, same thing can be done in a water pump, in a generator, or in a ceiling fan. I have seen recently a lot of smart ceiling fans, right? Even now you connect those with alexa and say like, alexa, turn on my light and on my fan. Now the intelligence is not there in the fan itself, it is inside the alexa, like it's a speech based system. But while giving the command, we may also few companies can come up with an intelligent fan as well, right? Instead of I am saying, it will detect like I am sweating, and automatically the fan will turn on, all right? Or if I'm like shivering, then probably it will turn off or something like that. So all these things, right? I mean, when we think about like automatically identifying the scenario, the situation, and then taking decision. And every time when we take decision, right, we think about lot of different parameters. We don't think about this is x1, x2, x3, and this is y. For an example, if I say like, should we have a tea break now? Okay, it's a binary classification, right? So but we don't think like in our day-to-day life, this is a binary classification. Oh, we have to fit a logistic regression or decision tree or a neural network. No. But in our brain, what happens again, it's neural network in our brain. But what we think like, oh, this presentation already started, I think already joy had some issue with connecting and all, so 5 minutes late, and then it started. So we just spent like 15 minutes from the start, and why should we have tea break now? So let's complete this. It's just a 1 hour discussion along with Q&A. So let's complete, then we can have the tea break. That is one decision. Then again, some parameters may come. Oh, it is like morning also, that in a Saturday. So I'm feeling like sleepy. Let me grab a cup of coffee, and then I will attend. Or there can be a hybrid decision, like, okay, I can bring the coffee immediately, and also listen to the lecture. Or you may think like, okay, this lecture is too boring, but I will not log out from Zoom. Let me there. But anyway, my microphone and video are on off. So let me have tea outside. So whatever, right? So these are all our decisions, right? And we control our decision based on all these parameters. right? And we think we sometimes take wrong decision as well, and then later on we thought, oh, why I did that, right? That kind of thing. So it's not like something which is 100% accurate also for human being. So same way, when we talk about AI, machine learning, and the outcome, and then oh, it is a hype, we don't get 100% result. That's true, but that happens to human as well, right? So any decision when we take, whether this particular color of the t-shirt I will buy, or that particular design of the t-shirt I will buy, but I have budget for only one t-shirt, then I have to take the decision. So for that decision also, I mean, as a human being, I always use all these parameters: the quality of the cloth, the paper, sorry, the color, the design, the print, in multiple things, the brand name, the price. So based on all these, then I will take the decision, okay, whether I will go for t-shirt A or t-shirt B. So what we did in must research, right? I mean, all these kind of things, right? When we thought like how human being thinks, or how we solve puzzle, how we solve problems. So let's focus on those. Those may not be very useful for corporate world, but that will be very useful for learning purpose, I mean, to understand how all these things are working. So then I came up with a set of problem statements, which called it like a cognitive solving cognitive problems with input as digital text, image, speech, and sensor data, and combining all these, right? I mean, a multimodal system, and where we'll be applying like definitely NLP, computer vision, audio, ASR, and all, and robotics to some extent. And then I rename this project as J plus O equals to Y. So this is not because of my name, but it's a puzzle you can just post in the chat box, right? If you understand why J plus O equals to Y. Okay, so going back to the innovativeness. So what I think, like in my opinion, the innovation should come right from, again, like from inside you, but you have to discuss with multiple people, you have to brainstorm with multiple people, so that you will get like a lot of ideas, and then form a team, and I mean, actually think out of the box, right? But because it's not like in real world, no one will give us like beautiful set of data and just request boss ek model fit kar do, right? That doesn't happen in customer. And they will also ask like what kind of data you want. Even they may say like, oh, which time period you want. What are the, we have like 100 different databases. We have different, so it's not a Kaggle challenge in reality, right? It's not like a single data set. We'll just put a SVM and get a result. It's not like that. But the system, when we design, we have to think about like many points. One of them is like whether it is adaptive. So if the information changing, right, then the goals and requirements, they may also change, and then the how to resolve this ambiguity and tolerate that unpredictability. For an example, simple example, this COVID-19 situation. Now the business, the lot of time series model what we had like last year, which went very well for last 5 years or last 10 years, that got failed. Why? Because this suddenly this pandemic thing happened, the COVID-19, and a lot of business got impacted. Few of them are doing very good. For an example, Zoom, right? A lot of Zoom license got sold. Or Google, right? They have started like all the schools are Google Classroom. But think about the airlines, British Airlines. Right? I mean, there are a lot of, I mean, the hotel industry, they got like hugely negatively impacted. So the time series model what they fit earlier, that is not working this year. And I'm not sure if, even if they enhance that, it is not a time series model, because we don't have like every year, we don't have, every year we have Diwali, but every year we don't have COVID. So that's the problem, right? Even the online shopping got increased, but that got also affected because people thought like even the delivery, I may invite COVID. So it has impact. So multiple things happened, and we think about like how our model, or the algorithm is adaptive in nature. And data scientist role is not like, oh, it model fit kar diya, ho gaya. No. So we have to also check like whether it is working well, it is performing well, it is getting the data, it is giving me the result, and whether we have to tune it, whether we have to tune the hyper parameters, whether we have to retrain the model. It's not like just deployment and then let the software engineer or any other team members work, right? So interactive is also very important, right? For an example, like, are we getting some feedback? It's similar to the reinforcement learning kind of thing, right? So how we get the feedback, and then it started interacting, and then definitely based on, as I mentioned, like I built some robots which can get your emotion. It will identify the person, gender, age, and emotion, and then based on that it will interact. So that's very important. Then iterative and stateful. So what is now? And as I mentioned, like suppose I am feeling cold, then I may go turn off the fan, or I will have I will grab a cup of coffee, right? So that decision is it's iterative, and in a particular state what's happening, because now I wear a jacket because I'm feeling cold. That doesn't mean that decision is a constant decision and I have to wear the jacket for the entire day. No, we don't do that, right? So again, we'll pull it off. Why? Because that time I'm not feeling cold, or I'm feeling hot or warm, right? So that all these things changes, right? So it's not like, so in one particular state what's happening, in another state it may not. So again, the through from that final state automata, and then I'm not going through this ANN algorithm. I think there are 100 different videos where they describe, like, this is axon, this is dendron in real brain, and this is what we are doing, like the input layer and output layer, or hidden Markov model. But these are all available in the internet. You go and study. But only thing is, like, what I'm mean to say here, these points, the adaptive, interactive, iterative, and stateful, and contextual. The last point, contextual, is also very important, because sometimes we discuss about a healthcare domain. Now in healthcare, right, I mean, if I use the word operation, that has a meaning. But the same word operation in military may have something related to war. The same word operation in mathematics can be operation research, or a plus minus. These are all operation as well, right? The same word in any other domain, like in IT operation, is a different kind of thing. So so it requires like a lot of things, like, which is related to that context. So because if you're using NLP, or if you're using computer vision, right, and the context is very important. Whether so object identification, if tomorrow Coca-Cola comes to us and says, like, all Coke products, you work on that. So I know the domain, that particular context. So then what should I do? Like, all the Coke products, and probably they are competitive products, I will take care. Not like each and every object in the world, and I will train a big model, right? So what is a particular domain, and whether it is related to that particular context, and then I can focus on that context. And then context to context, my model may also vary, because the way IBM Watson worked well with healthcare domain, the same way it didn't work on finance domain. So we had to change a lot of architecture on that. Like, not only the data set is changing, and the same algorithm or same architecture, forget about the algorithm, the same architecture was not working, because of the context, because of the variety of data. The healthcare, you have nurses notes, doctors notes, medical reports, X-ray report, MRI scan. Finance domain, you have some columns, some tables, and few charts. That's it. So I mean, what we started, like, okay, when I joined IBM Watson, I thought, like, okay, can we add new functionalities? So this was my first project there, and few members from Mast also worked, and then I got like first patent as well there. And then we enhance that again, to have a lot of similar systems, where it is, like, um, problem solving with text and numbers, or simple arithmetic problems. So if you see the rightmost table, I am just reading it out. Like, Adam had 5 apples, he gave 3 to Eve, how many are left? So first sentence is like, Adam had 5 apples. So it's a proper noun in our brain, because we got to know this is a proper noun. Then had is a past tense of have. Then 5 is a cardinal number, it is written. Apples is a plural of common noun. So it's so if I use Stanford parser or any standard NLP tool, it will give me this result. Right. And then he gave 3 to Eve. So who is he? Then I have to use some anaphora resolution. This is a pronoun, and this he is no one but Adam. So I'm connecting as a human being, I'm connecting in my brain. But if for a computer, it has to understand, like, okay, this he is not no one but Adam. Then gave, some operation is happening here, right? So then you're putting 3, and that 3 is written THREE. So again, in human brain, we are converting that 3 to digit 3. And to Eve. So now 3 what? Nothing is written. Whether 3 mangoes, it's not written. But we, as a human being, again, we understood, or assumed 3 apples. Then to Eve. So Eve is an indirect object. Apple was direct object, that it was in plural form. And Eve is again another proper noun, and that is in indirect, as indirect object. Right. And then the last sentence is the most ambiguous sentence. How many are left? So I think many of you have answered this problem like 2, right? Because you have done 5 minus 3, result is 2. But but nothing is written here, right? So all of us, again, as a human being in our neural network, with so many hidden layers and all, we thought like, how many apples are left with Adam? Correct. So that was what we thought in our brain. No one thought how many apples are left with Eve. No one thought how many apples are left with Adam and Eve together. No one thought how many mangoes are left with Tom. No one thought how many such and such, right? So it's very important, right? I mean, in this context. So the first sentence, second sentence, third sentence, all of these are related to the context. And why? How many are left? How many apples are left with Adam? We thought because the context started with Adam as a first person here, and then apples also was there in the context. So then definitely the question is for Adam, not for Eve, because the word, the phrase came later, right? So this is the concept and the context what I'm talking about, right? And then you may think like, why Joy has invented this system, although he's claiming he has the first patent on this, but we don't need this kind of system, right? I mean, I can solve this in 2 seconds, or microseconds. Like, I mean, the answer is two, or sorry, or even if it is not for only for addition or subtraction, even if you have done from some division or multiplication, but it is standard two arithmetic problem or standard one arithmetic problem. I don't need a computer or a supercomputer or artificial intelligence algorithm to solve it, right? It's a waste of time. Well, for Adam and Eve in this example, it is it looks like that. But now I am reading out the example here in the left side. Okay, a 6.8 kg toboggan is kicked on a frozen pond. It acquires a speed of 1.9 meter per second. The coefficient of friction between the pond and the toboggan is 0.13. Determine the distance which the toboggan travels before coming to rest. Now this project actually I mean, now the project that I'm describing can solve this problem, and it is actually a real screenshot of this cognitive maths that I developed, and it is IIT entrance physics question, and the system can solve it, right? So how now, is it easy like the same as the Adam and Eve? I don't think so, right? But it is actually easy, because if we actually write the algorithm proper way for a computer. For human being it is hard. Why? Because we are again very much biased towards our vocabulary knowledge, biased towards what we remember right now, biased towards what we can apply right away. Otherwise, we try to avoid situation which is complex. We try to avoid, we have some repulsion with this word toboggan, because it's not apple. Apple was very familiar with us. Earlier example had Adam had 5 apples. Now it is a 6.8 kg toboggan. What is a toboggan? The first repulsion happened. Then we forgot the formula of coefficient of friction. Many of us or all of us are from science background, but we forgot the I mean, maybe few of you can still remember, but I forgot coefficient of friction formula. Okay, pond and toboggan is 0.13, so it is doable, but I cannot throw the answer right away. Just I did it for this apples problem, right? So first of all, toboggan is not in our vocabulary. That's nothing but if you visit any amusement park, you will see that, like from top you can slide on that. It is actually, I think most of the water parks have them, but we don't know that it is called toboggan. That is one. Second is coefficient of friction. It is stored in your memory somewhere when you are in standard 10th, 9, 10, 11, 12, but now you forgot, because day-to-day life, even if you are using friction while you are applying brake in your car, or skidding, or even using eraser to remove any pencil mark from, we are using friction in our life, but we forgot. Even if when we fall down, we don't think about like 9.8 meter per second square. But this is physics, this is natural world. Only thing is like, we don't apply those formulas. So we have, what I am trying to say here, now for a computer we can actually store this, right? So we don't have to memorize coefficient of friction. We can still like have all these mechanics and then put it together. Now the problem is like resistance in mechanics versus resistance in electricity is different, because in here you have to use this coefficient of friction or viscosity, again it will come. But in electricity the resistance will be, again you have to apply Ohm's law. So then again, what is the thing? Context. So whether I am getting this problem for electricity or it is a problem for mechanics, can we get that from the words itself, right? If it is asking potential difference, it is asking resistance, current or something, okay, it's a problem of electricity. If it is asking about this kind of thing, then it is the example what I have given now with the toboggan problem, it is a mechanics problem. It's not electricity problem. But the word resistance can be used in physics in two different or multiple different ways. So you can search my name in Google Patents and get that first patent details, right? It's the second patent what I want to discuss again on how to get answers from a table or a chart, right? You have different kind of charts in which is in a document. Suppose the document is already printed. You have a print in a page or it is in a PDF file. So you lost the actual original table, right? No one will give you the original table also. Suppose you're reading a 5 years annual report of Microsoft. So Microsoft will not give you the raw table, right? So they will just publish the results in some graphs. So now, for an example, this particular chart, right? If you see, like there is a height of this rectangle. If I see in 1996, what is the number for 1996? This second column, the first one I can see 30. The second bar, it is something around 36. Am I correct? So 30, because it's touching this 30 line, and then it is just above 35 and below 40, but looks like it's 36. But the 36 is nowhere written in the graph. So I cannot use a simple optical character recognition like OCR, the Treasure Act kind of package, and fetch that data like this is 36. So what I have to do, I have to use that OCR to get like all the labels like 1996, 97, 98, so on in the x-axis, and 0, 10, 20, 40, and so on in the y-axis. And then I can combine, I can get like the height of the rectangle compared to this number of pixels and whether it is following the y-axis and corresponding x-axis. And then I can get like, okay, this is actually this measurement is saying 36.5. Even it is more accurate than the human being, where I can see like, oh, this is 36, or I can say this is 35, or someone can say 37, which is wrong. But using computer vision and this measured image processing, right? So and before that also we had gone through like chart classification and so on. So now this is another project like where we are applying these concepts and all. So this is the problem solving with vision. This is a pure mass project. No other like help from corporates and all. Only thing is like we did something on Sudoku puzzle solving. Now again, I mean, I'm repeating that same thing, right? So it's not about like I need a robot to solve a Sudoku puzzle. The same for the solving arithmetic problem. Why I build that solving arithmetic problem? Because many people think like we are weak in mathematics. So what I was trying to say like, okay, it's not about weak in maths or strong in maths. It's all about the language you're not getting, or you're not you couldn't connect the dot. So it's good for the students if they can connect the dots, and what we have done like step by step solution. The same for here, like Sudoku solving. I don't need a solver robot on behalf of me because I love to solve Sudoku, so why I need a robot? But the thing is like, first, number one is like whether we can have such kind of technology which can solve this, just to show yes we can do it. And second is we can have like step by step solution as well to teach someone who thinks Sudoku is hard. I have seen people hate numbers. I've seen they hate mathematics. A lot of people, a lot of students, and that from that age, like till now in their adulthood, they still say like, "Oh, maths. Oh, that numbers and maths. Oh, I'm very weak." Why? Is it like we actually the problem is like in our brain, that resistance, as I mentioned, right? The familiarity, what we love, like which is already familiar with our old things, what we learned. And then if it is not familiar, we think like, oh, it is hard typically, or it is complex, I don't want to get into it. So that actually then the same thing, like if we can't solve a problem, that I mean, actually the same thing can happen in our day-to-day life. Like any decision, any big decision when we are taking, we are applying our neural network, but it will be a problem, like, oh, this guy cannot take any decision, whether fast or slow, but very bad in decision making, that we hear right in our day-to-day life sometimes. If we can't take a fast decision, and fast and correct decision, and correct means again not 100% correct, but yeah, close to. So that is our objective, as a human being, and how to teach the machine the same, right? So we are machine teachers. If we have machine learning algorithms, then as a data scientist we should claim ourselves as machine teachers, right? So this is another project like with connected robots. So I talked about text plus image, and pure image plus logic, and now image plus IoT, right? So it's taking a picture of Sudoku puzzle, and not only Sudoku, we solved like almost 8 different newspaper puzzles. So it actually crawled over newspaper, took the photograph, and solved it. Now again, I don't want like a companion on a Saturday morning. A robot is coming behind me and reading the newspaper on behalf of me, right? But it's fun. Same thing like Alexa, turn on the switch and turn off the light. It's not so I mean big thing, but yeah, it's interesting, right? I mean definitely it's interesting with respect to the technology where we are going. And the most interesting part, like what we studied in our earlier days, like the statistics, the automata theory, language, grammar, everything is combining together, right? All of these things, also the domain knowledge, and we are combining all these things into AI, right? And then few robots are also there. I will show some videos. Before that, definitely it has a huge market impact of AI. Nothing new to tell about. And social impact is very important. So I want to keep in mind, like, okay, students, and to strengthen their analytic skill. That is one of my objective here. That's why those arithmetic problem and all this in a very comprehensive logic and all this. So how to have like step-by-step solutions. And then children with special ability, or not only children, for specially able person, like how they can get guidance by detecting image, text, voice. Like think about like someone has a challenge with vision, someone has challenge with audio, right? So all of these algorithms can help them. Like, I mean, we can translate something which in front of me, or we can visualize something which I cannot hear, but that particular voice we can visualize, and vice versa. And definitely, we are also working closely with multiple corporates and startups to enhance their AI research, incorporating with mass research. Like, and some of these components in J plus O equals J, and we enhance that. And we are collaborating with government, multiple governments, including government of India and multiple state governments, like to have these intelligent applications. Just to align with this digital India initiative. So sustainability is very important, like how we can, it's not hype, definitely it's not hype. And to keep in mind like the AI principles in mind. This is again quoted by Satya Nadella from Microsoft, CEO of Microsoft, and he mentioned like this. I really like them, and then I quoted and I love like he used the word must multiple times there. So AI must be designed to assist humanity. AI must be transparent. AI must maximize efficiencies without destroying the dignity of people. So we cannot say, I have an algorithm which can replace doctors. No, we never, we cannot do, right? When we first invention of mankind was wheel, and that was not replacement of legs. Although we have wheelchair, but the car doesn't replace our leg, right? So it's not replacing someone. It's just minimizing the effort. The same way the calculator came, we didn't replace our brain, right? So anything, the gloves, any machine, right? So if you recall the Three Idiots dialogue, right? Whatever is like minimizing our effort, human effort, any device, that is called a machine, right? And we are calling about machine learning. So it's not about replacing something, definitely not. So, and then it should be designed to the intelligent privacy as well, right? I mean, we know like many people are capturing data for applying this algo and all, but at the same time, as that guy said, like it will capture your behavior. He mentioned this word anyway. Then he corrected, like it will capture your different usage of applications. But anyway, that is also my personal data. So whether it is being sent to the server centrally, and whether they are combining all this data together, or the algorithm is inside my phone, those are the concerns. We have to think about the privacy. We know, like if I call hey Siri, and if even if my phone is actually in locked position, and I say hey Siri, so then it actually wakes up. Now how does it work? That means it is actually looking for the phrase hey Siri. So that means it is hearing me 24 cross 7, whether I said hello Sarab versus hey Siri. So where is the privacy? I mean, we have to think about those, right? I mean, whether Apple is actually capturing data or they're not. So all these things are very important. So same for like we have to also get like AI must have algorithmic accountability. That is very important. And in recent past, I have seen most of the data scientists, they come out like, okay, I am using this Keras, Kafka, and some TensorFlow. Those are all third-party libraries. Believe me, when I started my journey in 2002, I wrote my 2,500 lines of code on in C programming language for a neural network, having only two or three common libraries like stdio.h and those or math.h, nothing else. Even matrix multiplication I have to write by myself, and everything was written by me. I didn't use any third party library for AI. And nowadays, if I use like all third party libraries, fine, you are getting those, but please learn what's there inside. That's very important. And second is you have to take the accountability. Even if you're using third party library, I cannot say, this is from scikit-learn library, and I don't know, I have not written that, it is giving me this such and such accuracy, so bye bye. No. So if I have used that, then I have to take the accountability. I have to take the responsibility to understand. Even if it is open source, go and fix it, right? And then AI must guard against bias. So that means human bias. We still have a lot of human bias, right? Like what I like versus what I don't like. These are all bias. Whether we are taking decision based on gender discrimination, age, and all, right? These are all bias, right? We think like, oh, this guy can work till late night, that lady cannot work. Why? Right? Or we think like this is aged person, he cannot travel. This is a young bright fellow, he can travel. No, these are all bias. We are thinking from some dark mind set or some bias in our brain which is already there from our society, from multiple other things we got, and then we grew up with those, right? But which is wrong, which is a human bias. So can we remove those bias completely through AI? And then it will be much much better than human being, because we compare like, oh, human can do better than AI. Now we can actually think about like AI can do better than human, at least if we get rid of these stupid bias but we have still in mind. Then is community, definitely to develop the community, right? I mean, through AI, by creating new jobs. It's not about only fitting algorithm. As I mentioned, that's 5% of the work what we do as a data scientist, fitting the algorithm or crafting the algorithm. 95% job is just the other things, getting data, collecting data. Again, my first project, I collected like 0 1 2 3 up to 9, all the 10 digits handwritten, actually distributed A4 paper to my friends and colleagues and their friends and colleagues without social media. So second degree connection, right? So I requested my friends like, can you give it to distribute to your friends, and then again collect it back. And then it was like a 10 cross 10 grid, 10 times zeros till 10 times 9. So each page had 100 different handwritten digits, and in any color, any thickness of pen and pencil, right? They wrote and gave it back. And then I wrote a program which automatically scans, because it's a constant size A4 paper, and the grid were also printed. So I know the grid locations, the XYZ of the grid. So I scanned them, again manually scanned using a scanner, right? And digitized them, then wrote algorithm to actually get those bounding box of the all the digits. And then I have label data, because anyway those are, they have written in the cage, right? So I created the automatic labeled data set, which and now is combined with the MNIST data set. So I donated that from Indian Statistical Institute. So in MNIST, whatever you see, some of those digits are actually written by me as well. Okay, so now, so that was a project in Indian Statistical Institute, ISI, when I was a researcher there. But the thing is, like, that is something where you have to think about, like, from scratch. Even something is available, but try to get like what is available and how I'm getting, whether I'm understanding those. So in mask research, but we are focusing on not only like this creating, and like we recently started mask academy also, like I will talk about that. And then sharing not only infrastructure, sharing algorithms, sharing libraries, right? And then how we can bridge the gap between academia and industry. And then definitely we have to have this mission Intelligent India, like with this AI thing, which is aligned with Making India, Skill India, and Digital India. So think about Intelligent India, and we have to be like number one nation with respect to all these latest technologies. So yeah, we have collaborated with multiple organizations, like with NASCOM, with Analytics Vidya. So I believe in like in collaboration rather than competition, right? So when we I mean actually work together, we can achieve more things rather than working in silos and then getting like in a half-baked product and so on. So we have activities like create the pulse, arrange lectures, like and then explore, ideate, maker events, like a lot of hackathons. I think I will discuss with Sarab on this, right? I mean, how we can collaborate more, and we can take it forward, like in a more research kind of a environment. Like we know, like I mean, we have deliverables which is important for customers and all, but we should always have like a research wing, and I'm happy to collaborate on behalf of MAST, and so that we can create the great ecosystem along with the societies, and especially the ground level work like healthcare, agriculture, education, right, which is very important, at least in the rural area as well, and then for urban area, smart city, transportation, retail, and so on, right? So and we can actually start working on that. So the ecosystem is very important, like as I mentioned, like I mean, how we are collaborating, and then definitely to aware this, I mean, to grow the awareness of this. So yeah, I'm end of my almost the session. So feel free to connect with me over LinkedIn. I am very active on LinkedIn, so just search Joy Mustafi on LinkedIn, and when you are sending a connection request, please mention like you attended today's session in a message, so that I can easily identify who are you. And then if you're interested, join Must. Must Research Club is an entity where anyone who has interest in data science or AI and ML, they can join. It doesn't mean like you are a data scientist already. If you have interested, willing to learn, you can willing not only learn, you can contribute with your technology, right? The contribution here is the technical contribution, and then you can be like one of the speakers in any of the events, right? We write a lot of papers, we work in multiple so right now the 7 different cities are active now. Due to lockdown, we are like across the nation. Earlier it was only like in Bangalore, Hyderabad, Bombay, Kolkata, Pune, Chennai, and Delhi, and New Delhi NCR. Those are the 7 locations where the meetings happened. Now we stopped the in-person meeting, the monthly meeting. We are on Zoom, right? But the advantage here is like now every corner of the nation they are joining. Disadvantage is we are missing the cup of tea. That's very essential for research, by the way. So yeah, but we'll again open up the in-person meeting once the situation is normal from COVID-19. So, and there's a new program, Master Research Academy, because what we felt like in Master Research Club, when people joined, they thought like we will be learning and someone will be teaching. Well, the learning and teaching is different, right? So when I am willing to learn, I can learn from anywhere, right? But I cannot expect like some person will actually teach me. But if I need a teacher, a supervised learning, right? So then we should have a proper course and all. So this is very much affordable course we launched. It's called Must Research Academy, or academy.must.co.in. So any one of you who are interested, or you know your friends and colleagues, I know you are experts already. So if you have your family, friends, or colleagues, let them know about this. If they are interested in data science, we can have, we can teach them. So we already launched this program. The 4th batch is coming up in December. The batch 3 is running. So, and it has no age limit, so at any point, but definitely not like very early age, so 18 plus, right? So not like the for kids, right? But yeah, professionals and students, they can join this program. Yeah, so I have 5 minutes left for Q&A, so I will just stop my presentation, stop sharing, and as I mentioned, just explore Musk Research, connect with me, and we can exchange numbers also, get in touch. So I'm just stopping this session and the screen sharing, and uh, let's go back to the question answer. Yeah.
Thank you, Joy. That was a very enjoyable session, as always your sessions are. I've got a question here already typed in that is, after identification of problem using computer vision,
Hmm.
how to identify the different states of a problem and solve for it. More so because a physics problem would be very different to Sudoku.
Yeah. Okay. So two different things is right. One is like the identification of problem using computer vision. So that is like you're thinking about like scanning a question paper. So right now, what I have used is a digital format already. Like the question paper is in a digital format. I am not using any scanner on that. But yeah, if it has an image, right? For an example, in a physics problem, we also have some images beside that. Like, okay, this is a plane and there is an object, right? There is an angle and all. So that's a very good. So right now, what I have done is only on text base in the problem statement. And computer vision we use for the statistical, the data interpretation, like the graphs and all. But if it is in a geometry and physics where you need an image as well, so that work needs to be done. So it's very good. I mean, we are doing that research because there are also a lot of classes, different classes. The geometry, like if you have a triangle. Now, again, going back to school problems, right? Suppose two angles are given, and another angle there is written x. Now the question is find x. Now, one angle is suppose 35 degree, another angle is 45 degrees. So what is x? So that kind of questions can be done. So that is being used with the computer vision. So we started with that, but with physics also there are a lot of problems where I understand, like you have like resistance, like so that resistance signal. Then you have a circuit diagram and say like this is the resistance here. What is the total or what is the potential difference there? So we have not done that. So as of now, for physics we have written only completed the text portion, which is actually described only through text, not no image required. But yeah, we can combine these two, the geometry and this, and then the same logic, similar logic can be used.
Great, thank you, Joy. So, Joy, I know natural language processing has been your forte for a very long period of time, and you also teach in that. What is your view on what is happening right now with GPT-3 and so on? Are we is NLP becoming a solved problem as such, or what are the big challenges there?
No, I mean, see, the computer is still garbage in, garbage out, right? So whether we have the traditional classical NLP with Stanford parser and all, when we started our NLP journey, right? The typical POS tagging, parsing, semantic analysis, and so on. And nowadays, like, okay, you throw data and GPT-2 because, but the data what we have to throw there, that also requires lot of cleansing, because otherwise these algorithms, this especially the black, using kind of this kind of black box like gp2 gp2 or 3, right? The thing is, like, if we go there inside and check like what relevant data we have to actually push and whether those are perfect for the solution, then it is good. Otherwise, what's happening, including like the for computer vision also, I've seen the same thing. Like if I just blindly use a cnn, that's a problem. Like, so whether we have a relevant data and for the particular problem, and clean data, and then a lot of pre-processing and post-processing should be also done. So that is one. Because the CNN, I have seen one thing, like we thought about a logo classification. The one guy came and said like, Joy, I want to solve simple like Samsung and Lenovo. Two logos are there, two types. So I collected all images from internet, and it has like some 1 million images from Bing search result. It's a paid project in Microsoft, not like deliverable, but it was, on his experiment he wanted. And he said like, I am getting some 97% accuracy with this classification. I said like, how many classes you take? Like, he said like Samsung, Lenovo, and a third like nothing or not applicable. And fine, three class classification. So I went and then I just cropped an image of Samsung logo and I passed it. So it was showing me not applicable. Then I again cropped an image of Lenovo logo. I passed it. Then it is showing not applicable. Then I asked what happened. He said like, let me check my data. So what he did, he just trained all label data for Samsung, all label data for Lenovo. But that was not logo. So the data set what he captured was actually images of most of the Samsung images came for phone, and most of the Lenovo images came for laptops. So finally the model built was Samsung, not for Samsung versus Lenovo, but the model was automatically trained for mobile versus laptop. Now you put an iPhone, it will say Samsung. You put a Toshiba laptop, it will say Lenovo. But if you crop the Samsung logo and crop the Lenovo logo, it will say not applicable. So that was a wrongly used CNN. But the thing is like, there is no point, there is no, so I don't see like CNN is bad. It's all about like the usage of this, right? So usage of proper algorithm on proper data set. Otherwise, it will be finally computer is garbage in, garbage out, right? That is very important. So including GPT-2 and 3.
Right. And I mean, to you, what are the big challenges? I mean, as somebody, starting off in here, what are the areas that these youngsters should be focusing on that are going to be the, big challenges of AI? You've kind of mentioned, these black boxes and opening them up, obviously,
Yeah, that is one,
and
definitely.
explainability is one. But what other applications do you think, or areas should they be focusing?
I think playing around the data, that's very important, right? So even if you say like, okay, the MNIST data set you collected, can you actually open the image, see that the 5x7 matrix, zoom it, check where is, how the zero is written, how the one is, think from you are a computer. Like if I am the computer, I am reading this text, I am reading this diagram, or I am reading this image, or I'm hearing some word, a bird's chime, a fan's noise, everything. Think from that, like this is data for me as a human being, and then try to think like how I can write a program where the computer will also observe the same on behalf of me through an algorithm. That's very important. Don't use any black box. Fine, you use black box, but make it white first. Get
Right.
inside, you understand, then use. Do not use anything which you don't understand. That's very important. That's the bottom line, what I want to, at least for the new generation, because from our thing, like we actually had to learn. I mean, there was
Libraries
no
didn't
choice.
exist, so we had to build them, right?
Library means book library. You have to go book
Right.
library, borrow the books. That's it. You read the papers, then write your program.
Yeah, yeah. And one of the things that we find a lot right now is the fact that people are very focused on being able to learn how to use libraries rather than understanding the inside of what is in the library. And like you have mentioned, and I'm glad you mentioned this, what I have found a lot is that people actually don't know, even interpret how the inputs should be, and so they actually end up with the completely incorrect outputs from that, right? And this is one of the big concerns that I see in kind of machine learning applications today.
The
That
same example, the
again
logo
has,
example I gave, right?
yeah, yeah, yeah,
Because he was
absolutely,
claiming like it's 97% accurate, because with his training data, it was showing that accuracy. But in
yeah.
reality, it was actually mobile versus laptop classifier, not a
Hmm.
logo classifier.
Yeah.
But it
So in
happened.
fact, we had a very interesting talk last week from a PhD student in the US, Manas Kaur,
Okay.
who was talking about how you can now incorporate knowledge graphs along with deep learning algorithms to
Yes.
make them more explainable, right? And do you see that as being kind of the next stage
Yeah,
of
that I'm using already,
incorporation?
right?
Huh.
Sort of in the problem solving, the physics problem, right? That we
Right,
knowledge graph.
right. Okay, okay.
But I'm not using deep learning there. It's still classical machine learning. Uh,
Right.
yeah.
And of course the big question is, I mean, right now all the focus is on neural networks went through a boom and bust. Do you think that we have gone beyond that point now where neural networks is the future, or do you think SVM and all of these other algorithms and the kind of cognitive thought process still matters? Because I mean, obviously the neural computing side is very different, right? It's
Only
very
thing is like,
statistically.
yeah, understand. So if I again recall my journey, right? I started with neural network, even
Mhm.
even before I learned decision tree and SVM. So,
Yeah.
but what I learned in neural network when I wrote my own model, it is nothing but start with again linear regression, right? So
Right.
because in human mind, we actually think linearly. कि इतना पैसा डालेंगे क्या आएगा, right? This what I am doing, what will happen? So it's we think linearly. Okay, we don't
Right.
apply any. So then what happens inside? Then that linear, that y equals to mx plus c, or y equals to alpha plus beta x, that line, then we are putting in a sigmoid when we are taking a decision. So
Mm.
now inside the neural network, inside the activation function, if I am applying sigmoid function, so then I'm transforming my linear decision into a binary decision. And now if I am putting multiple nodes, then we are combining this for the hidden layers, and every node it is being, the weights are being generated. Now for the same model, the ANN, the simple simple artificial neural network, once we have multiple models and using in a recurrent way, that we are calling deep learning.
Right.
So Deep learning is not nothing new, or it's not a different thing. It's just a complex architecture we are putting. But finally, we are thinking again linearly, right? So if the activation function and we go back and down, so linear regression, say logistic regression, that logistic regression inside activation function, from there the weights are being generated, then the hidden layers, and then you have multiple such networks using either convolution or using recurrent or using LSTM, like looping back. That's it, right? So it's simple. It's not hype. It's just like I should not say old wine in new bottle. Definitely, it's new wine in new bottle. But the concept, right? It's still wine. That's important. We are
Right,
still using grapes.
right. Excellent. Okay, well, Joy, thank you so much. We've been talking about, officially collaborating between Sabudh and Mast, and I hope that this is the start of that.
Absolutely.
And, I think, part of what we do during the 6-month program, the students come to us is actually develop passion projects, which is very much along the lines of what you've been talking about that the Must Research Group is doing as well. And I think that's an ideal place where we could potentially start to work together with some of the students here, working on some of the must projects as part of their whole program, right? And I think we would look forward to your input more often,
Absolutely.
and have you as a recurring speaker rather than a one-off, right? So we look forward to having you back again. And thank
Not
you
only
again for
speaker, I
taking
would
your
love to
time.
be involved in projects also. We'll discuss offline.
Yes, yes, lovely. All right. Thanks, Joy.
Thank you.
Take care. Bye bye.
Bye.